Newton's law, forces. So they will be looking at forces that we will be working with as much as in future videos we will be exploring Newton's laws 1 to that. So there are forces. Okay, first of all, you should know the definition of a force. Since the first grade or whenever you started in school, you knew that force it's it's a push or pull on an object, or this can be exerted conduct or non-conduct, bringing up another new word, conduct forces. Conduct forces, I can't get it right, versus non-conduct forces. Okay, conduct forces are exerted between objects that are conducted with each other, like physical conduct, and non-conduct, as the word describes itself, are forces that exist between objects without any conduct. I'll mention few examples of non-conduct forces. Those are electrostatic force, gravitational force, and magnetic. All these forces they can act on objects without being in contact with. You should know that magnets can pull and push things without being in contact with them. So is gravity, is pulling the ball, like projectile lesson that is in the past, pulling a ball without being in contact with. So is electrostatic force. And for conduct forces, of which they are most common, uh, we have a couple of them again. And these are applied force when you're pulling or pushing the box, a tension maybe when you're pulling a box through a rope or something like that, or friction when a box is rubbing against the surface. A force that is also need contact as much as a rope need contact, and when you're pushing a box using hand, you also need contact. Those are all contact force. And a normal force, a force that or a surface exerts on an object that is in contact with, as the definition says. The normal force that we'll be working with here is the normal force, yes, because most of our calculation will be involving the normal force. What is exactly a normal force? A normal force is whenever there is like a surface and an object. A surface will always exert a force to an object. It's always going to be like that. Whenever there is a surface, there is a normal force. So the correct definition for it, a normal force is a force that is exerted by a surface on an object. Simple definition as it is. Since we here like normal force is counteracted by g, the weight of an object, which is always this way. So since to keep the object attached, or to keep the object stationary, there are always two forces. If the object is on a surface, there are always two forces acting on it. It's always the normal force pulling it up and the gravity pulling it down, so that it can stay stationary. As much as we put our objects on our table, they stay there forever, because unless someone steal them, they stay there forever because two forces acting on it. Those forces are normal force, which is always there whenever there is a surface, and there is g. G is always there whenever you are told to draw free body diagram. Free body, I forgot to mention, these are free body diagrams. Free body diagrams, whenever you're drawing a free body diagram, G is always there. This is just a free mark. Like, you always have to put G. And a normal is almost always, because whenever there is a surface, unless if you're told that there is a pulley maybe in somehow, and there is a rope and some object is suspended. If it is suspended like this, maybe object A is suspended, that where you don't put your normal, because normal force always work with surface. My spelling, surface, it's always work with surface. In G, the universal one, is always working with the object. When it's an object, always there's something that is pulling it downward, as in for this case, G is pulling it down, counteracting the tension that is pulling it this way. So there is tension here and gravity working together. And for an object put on a table, there are always two forces, again I repeat, normal pulling it upward and gravity pulling it down to keep it stationary. For some reason, when you're drawing a free body diagram, I always advise students to draw a line like this, like in maths, to show that since these are only forces acting on this object, they are equal. You know, you do these marks in maths to show equal sides. Even here, you have to draw this because you are not going to exactly draw your free body diagram into scale. So I advise people to show if only if G is equal to normal, then you can show this marks to show that they are exactly equal, no other force acting upon it. Enough about normal force. And on our workings, progressing with the physics, we'll be also mentioning a force called frictional force. Frictional force is also due to surface. Um, it opposes the motion of an object that is in contact with. Okay, but for frictional force, there are two frictional force type of a static one. A static one, as you can see from the word, it's it's a force that oppose. Um, okay, it's a force that oppose a tendency of motion of an object. So it's a tendency, not exactly motion. So these ones act on a stationary object. So not moving here, not moving. It is not moving. And there are other ones that this one we call kinetic. Kinetic. Kinetic frictional force is a force that opposes motion. Simple. So in this type, something is moving. This one always opposes direction of motion. So if there is an object like this, and it's moving this way, and friction most obviously is always going to move this way because it opposes the motion. So whenever you told motion is some direction and oppose that direction is kinetic frictional force. So is for static frictional force, of which it's oppose a tendency of an object to move, not exactly the motion. Because on defining frictional force, I did mention that it's acts between the surface that an object is contact with. So because there is contact involved and the surface, we on its equation or its formula, on calculating it, you're going to involve normal force, and this one is a coefficient of friction. So this is an equation that you use to calculate your frictional force. Okay, this formula not exactly written like this for both cases, for kinetic and static. For static frictional force, there is always an S here and max here. Yes, max here. Why there is max there and static? It means that it's a frictional force on a static object, like object that is not moving. Max, because after whenever like you, okay, let me say this is a frictional force versus a force applied, a force that you're applying on an object. Okay, whenever it is a frictional force, force applied on an object, this is a friction. Okay, whenever you're pulling an object, the object doesn't just simply move. Maybe you don't notice that, but for heavy objects, let me say you're pushing a car, it sometimes don't move exactly instantly as you're pushing it. So first, the thing that applies static frictional force before kinetic frictional force. Simple as that. So first, you're applying a force on a car, you're fighting against static frictional force first. You fight against this, or should I say you're battling against this, and for a second time, you now the object is moving. So you're battling against a friction that opposes a tendency of, okay, this here, the friction is opposing the object from moving. Now it's opposing an object that is moving. This is two when you're pushing a car. So first time you're pushing a car, you are battling against static frictional force, increase till it's reached a point where we call it maximum static frictional. So it's max. This is it. That's why if you're calculating this, you're calculating exactly this. And after that, after you have battled with a static frictional force, then object will start to move, right? So now you are battling against a constant kinetic frictional kinetic frictional force. So first you're pushing an object, it is static, it's not moving, you're fighting against frictional force, and when the object is moving, now you're fighting against kinetic frictional force. So whenever on your paper you're writing, choose your formula wise. Whenever the object is said to be not moving, you put your max there on your F and your S there. And whenever the object is said to be moving now, there is no max here, there is no S there. Oh, sorry. Yes, there is F, but now on the subscript of F, now you're going to put something else, not S, of which is K for kinetic friction, but everything remains the same. Simple. The only change that you put there is the max that you remove here and the K that you put here, and the K always go with the K here, and same applies with the static. You only change those, but the formula all in all is just freaking same. Thank you for watching. Subscribe, hit like if you like, and comment for content that you wish to see in the future on the series of physics. This is Fun Maths Function with Sitabisum San. Thank you for watching.